Chapter 4.1 Day 2, we're looking at graphing polynomial functions. So the end behavior of a function's graph is the behavior of the graph as x approaches positive infinity or negative infinity. So, for example, x is approaching positive infinity, so it's going to the right. The x values are increasing. Negative infinity for x is to the left, as the x value is approaching the left. For the graph of a polynomial function, the end behavior is determined by the degree and the sign of the leading coefficient. So in the previous lesson, when we were talking about degree and the leading coefficient and rewriting it, and knowing whether it's a polynomial, it comes back with regards to the end behavior. So let's take a look at some examples, some general examples. So if we know the degree is odd and the leading coefficient is positive. So an example of this would be, not just the front, would be 2x cubed. So it's odd, it's positive, so something like this could be the graph. Depends on everything else included behind the 2x cubed. So let's take a look at our end behavior. We're looking at what's happening to this left side. So we're looking at as x approaches negative infinity, because that's an arrow. That is read as x approaches negative infinity, meaning the x values were going to the left. What is happening to f of x? Now remember, f of x, another word for f of x, is our y values. So what's happening to the y's as x is approaching negative infinity? So what's happening here? It is going towards negative infinity. It's going down. So the y values are approaching negative infinity, or the y value is going down. Now let's look at the right side. So as x approaches, these x values are approaching positive infinity, or just infinity. I'll write positive for now. As x approaches positive infinity, it's going to the right. F of x, or our y values, f of x is approaching which direction? It's going up to positive infinity as well. So it's going up. Okay, now let's look at odd degree still, and the leading coefficient is negative. So remember, if there is a negative in front, it's a reflection. So an example of this would be negative 4x to the 5th power. So it's going to flip around. Maybe the graph looks something like this. So the middle portion could be anything in between. So for example, negative 4x to the 5th. So let's see. As x approaches negative infinity, so as we're going this direction, what's happening to f of x, or our y values? Our y values, in this case, are going up. So therefore, that is positive infinity. Then let's look at the right side. As x approaches, so this is our x values, it's approaching positive infinity, or just infinity, our f of x, or our y values, are going down. So down means negative infinity. So notice that the odd, that they are going opposite directions. So odd goes in opposite directions, and the sign tells us whether it's going up on the left or up on the right. So let's look at degree when the degree is even and the leading coefficient is positive. So an example of this would be 7x to the 4th power. So positive, let's think about something like this. So just like our exploration on yesterday when we were talking about some of these graphs. So even and positive, 7x to the 4th is an example. Now let's look at when x approaches negative infinity. So as the x is approaching negative infinity, what's happening to our y values? Our y values are going up. So that means f of x approaches positive infinity. Then on the right, as x approaches positive infinity, we're going to the right, then the y values are approaching also positive infinity, or just infinity. Now, if the degree is still even, and the leading coefficient now is negative, I'll give us an example that hopefully we know really well. Let's say negative 6x squared. So even, and it's negative 6x squared, and so we kind of know what that graph looks like. So it's a parabola, and it opens down. So let's talk about the end behavior. As x approaches, it's going to the left, negative infinity, our y values are approaching negative infinity. Then on the right, as x approaches positive infinity, the y values are also going negative infinity, just like the left, right? They're going exactly the same direction. So maybe if you like words to kind of help you out with, how do you know which direction the ends are going? Odd, it goes in opposite directions. Even, it goes in exactly the same direction. If it's positive, it's up. Even, it's down. For odd, positive is like a positive slope. That's what I think of, like y equals mx plus b. It's a positive slope. And then for negative, it's a negative slope. Okay, so it's very similar to that. So let's look at just describing some end behavior. So we need to identify the degree and the leading coefficient. That's all we need. These are written in standard form, so we just need to look at the first term. So the degree, the exponent, is 4, so that is even, so you could write 4 here. Leading coefficient is negative 0.5, so therefore we know it's negative. We don't really need the number, we just need to know that it's negative. So even negative, we look at our chart up here. Which one does that match? Which one is even? Even, I know, is at the bottom. And negative, it does something like this. Now, the middle part doesn't really matter, right? You're just looking at the ends here. So this one, let's sketch. It's probably doing something like this. And so we can do x approaches negative infinity first. The y values are also approaching negative infinity because it's going down. Then if we look at the right side, as x approaches positive infinity, then the y values are also approaching negative infinity. Okay, one more example. The degree is odd here. Leading coefficient is positive, so odd positive. So it does something like this. Looking at the chart, this is odd, and this is positive. Then we look at the left first. As x approaches negative infinity, our y values are going down, which means it's negative infinity. Then on the right, as x approaches positive infinity, our y values are increasing, going up, so f of x approaches positive infinity. So try these two down here, number 2 and 3. All right, so we tried this out. So this is an odd degree, 3, and leading coefficient is negative. So the graph is going to do something like this. Again, just the ends. So as x approaches negative infinity on the left, then the y values are increasing, so positive infinity. On the right, as x approaches positive infinity, the y values are approaching negative infinity. For number 3, even, leading coefficient's positive. It's a parabola that opens up. So as x approaches negative infinity this side, the y values approach positive infinity. But on the right, as x approaches positive infinity, the y values also approach positive infinity.